Yeah. No animations for you. No animation. Not even slides.
I think we should start, right? Okay, guys, it's time to start. Yeah. Okay, good afternoon, everyone. Welcome to CCAMP session. So actually, this time the agenda is really very busy, and Deborah asked the chairs, it's better for us to end the session 10 minutes earlier, and then for people to take the bus, to leave more time for the social event. So, yeah, I will quickly go through some general information that has been, repeated 100 times, maybe. Okay. Okay, loudware. I think you know it very well. Skip. So please speak in front of the mic and state your name before speaking. And also for the minute taker, it will be much appreciated if anyone can contribute the minutes over the, through the Etherpad. Yeah, okay. I think Hao-Mian can help us at least. Session, this one. So, actually, this time we have plenty of jobs, actually, 23 jobs, 15 slots. So the agenda is really busy. And actually, that's very good that CCAMP is still, glowing. So for the IPR process, yeah, so the contributors or, co-authors, you have to, reply the IPR call as soon as possible. Otherwise, it will, slow down the, WG process. And we always encourage people to use the mailing list as much as possible, especially, for example, to introduce some new topic, to discuss some technologies. And also, especially, we need to use the mailing list to build the, WG consensus. Okay.
Okay, short update on the status of the working group. We have no new errata, no new RFCs since last meeting. This doesn't mean that we have been lazy, because we have 2 drafts ready for working group last call. The APR polling is already done, and we have 1 draft ready for working group adoption polling. We have 1 draft in the editor queue and one in the ISG processing. Next, please. Okay, so we have 5 drafts on the agenda. First one is the microwave framework. This is one of the 2 documents that will be last called immediately after the end of the meeting. And we will have all the young models for WSON, microwave, and OTN presented today. Then we have the framework for WDM interface management and control, which is the second draft that will be last called after the meeting. The next draft that we will progress is the RSVPT bandwidth availability. We will launch the IPR declaration request after the meeting. We have the transport MBI use cases, which will not be presented, but we have 2 use cases presented today. The WSON impairment validation information model, which doesn't have major changes compared to the last meeting, and the OSPF availability extension, which is in the ISG processing. No liaisons, neither incoming or outgoing, which is quite strange. And that's it. Let's start immediately and try to save as much time as we can. Unfortunately, this wonderful thing doesn't work, so you needed to ask Fatai to move the slides for you.
Hello, everyone. I'm Amy from Huawei. So I'm going to present the two working group drafts. It's both from the microwave design team. The first one is on framework draft. From next, please. Yes. So the changes from the 01 version is that we add some tests to indicate that in the young draft we decide to move some parts could be generic for other technology use. And then we also add some tests to describe that what we have done in last IETF hackathon. And another update is we have a new co-author, Daniela from Nokia. And immediately when we finished update on 01 version, we found that we have left empty on the security section. So we have another 02 version. We fill up with the security section and also fix some editorial needs. So there's no technical issue open for today for this framework draft. Then I think the next step will be the working group NASCO. Okay, so the second one is on the young module. Okay, next please. There are two main changes from the 01 version. The first one is that in last meeting, we received some comments to review the model if some part could be generic for other technology use. Then we revisited the model and we decide to separate the interface protection part as a generic part. So this one could be used by other technologies if they are interested. It's on the interface protections. And then the next changes that we also update the models to make it the NMDN compliant. Next, please. So this slide shows the details about how we use that the protection part. The left side is the generic interface protection, and it's defines some, for example, protection types and the working entities or some other related protection related objects. And then in the micro radio link part, we make use. Actually, the arrow should be right to that direction. We make use of the interface protection module and to use that in our microwave specific module. So this is for the protection groups. Then next slide, please. So another update is NMDA campaigns. So it's just reorganize and rearrange on the modules. Okay, that's it for the update. And the authors believe that we have finished all the technical work and the model is being complete and stable. So we would like to ask for working group NASCO. Okay.
Thanks a lot for being so quick. So before moving to questions and comments, we had a chat with Deborah, with the members of the design team, and we decided to close the design team. They did an excellent job with also a prize at the IETF hackathon. Was it in Prague or in Chicago? In Prague.
Yeah, best overall.
All the deliverables have been delivered. They've been adopted by the working group, and they are stable and close toward the working group last call. So thank you very much for all the hard work that you did. Now, this doesn't mean that we are not accepting any more work or contribution on microwave. Obviously, this was just the starting point. And that's it.
Okay.
Thank you.
Actually, I also would like to take the stance. We are also considering for next step to visit the topology argument for microwave. Okay. Thank you.
That's good.
Okay, good afternoon. My name is Zhou Yufan from Huawei. I will firstly introduce the changes of OTN topology drafts. In the OTN topology draft, they are in the introduction part, we add a clarification about the interface independent, and the applicability of the models is described in another draft. And for the Young model, the name attributes are removed, and as they are covered already by the TE topology model, and the client-facing related attributes in the LTP are also removed. And there are three attributes: TPN range, TS range, and TSG, added to the link attribute. Next, please. For the newly added attributes, and they are especially for the TPN range and the TS range, they are they are for the interdomain scenarios. In the interdomain scenarios, for example, in the ACTN, in the context of ACTN, the MDSC need to configure the interdomain links. So it's the MDSC need to know the information for the interdomain links, and each PNC will report the informations like the available TPN and the available TS range, and it's similar for the TSG, the granularity for the link. And next, thanks. Now this is the Young tree. Currently, there are still some attributes not to be removed, as they are covered by the TE topology model, by the unreserved bandwidth attribute. Next step, we will remove. And currently, this model is NMDA compliant. And next, please. And so for the next step, for the OTN topology model, we will remove the attributes which are covered by the TE topology model, and to align with the TE topology model. And we are thinking about whether to report the multiplexing hierarchy of the interdomain links, as there may be different multiplexing hierarchies on different domains. Or we can also just simply assume that we only consider the single stage multiplexing is also okay. So it's it's open to the working group, so you can discuss about this attributes. And the next phase. And for the OTN tunnel model, next, thanks. The changes are simple. We align with the current T tunnel model, which is NMDA compliant, and we add an RPC for path computing, and rename the transport types module to the OTN types module, and the information in the module is keep unchanged. Next. Here is a Young tree data tree for the OTN tunnel, which is compliant with MDA. And next, thanks. And for the newly added RPC, it's used for path computing. And the input part, there are three parts, which is a general input and constraints for path constraints and label constraints. And some of the attributes are covered by the path computation drafts. So the next step will align with the path computation drafts to see how to revise or just move the sum of the part to the path computation drafts. And next. And for the input part of the RPC, sorry. For the input part of the RPC, there the general input part, such as request ID, source destination, and the priorities. Such kind of attributes are already covered by the path computation draft. So may remove these attributes. And next. And for the path constraint part, for the primary path or the secondary path, we use the ERO explicit route objects are used to describe the segment of path. And next. For the label constraints, it's the same as the OTN tunnel model, the data model, to describe the end of the tunnel or of this path, or the end of this path. And next. For the output part, it's also represented by the explicit route objects for all the primary paths and the secondary paths. And next. For the next step, we will align with the path computation draft, and any comments are welcome. Okay, so it's for the OTN topology model and the OTN tunnel model.
So just one quick comment. I think besides you need to align with the path computation draft, you also need to align with the T-tunnel draft.
Yeah. Yes.
Hi, my name is Yang. I update WSUN Yang model. Next. Yeah, I think because of NMDA issue, finally we are NMDA compliant, and actually we also introduced a TWSUN type model in this draft, which is another Yang module to place all WSUN specific information such as WSUN node types and the application code for based on IETF G.6982 for the compatibility for the proprietary interface. And the wavelength assignment policy is all under TWSUN type module. And also we cleaned up so that we only augment WSUN specific link attribute from T topology model. Next. Yeah, so this is basically WSUN topology model. As you see, a lot of augmentation from T tunnel model, T topology model, and only we just kept what is unique for WSUN. Next, please. So I think most the basic work is done, but possibly impairment data we can integrate, introduce as a link model in the next revision. So that the MDSC can use those impairment data for path computation. So this is one thing that remains to be done. Okay, so it's not quite stable yet. Okay, all right. Any question on topology model?
Dieter Beller, Nokia. I have a few comments. There is no definition in the draft regarding the channel numbers. I think you are defining those in the wavelength range type. So what are the channel numbers that are being used in the draft? How they are defined?
So which one you're talking about?
The
Channel number?
W's on Yang 08.
So
Which page?
here, there's a Yang model here, right? Yeah, which attribute you're talking about?
The channel number.
Channel number.
Yes.
You think that's in the T topology model?
No, I'm asking, where is it defined?
Oh, what is channel number?
Yeah.
Okay. Could you flip through Yang model for that? You know, I forgot. I need to look at my Yang model. Yeah, but we can talk offline. Okay. Yeah.
And I also have a few questions regarding the grouping.
Sure.
Use some link attributes. I think there are also some issues that should be discussed. We can take that offline. I don't know whether you're.
Okay. Okay. So
Yeah, I have one question, one comment. So regarding the next step, you said that you are going to add some impairment data on the topology Yang. You know, actually, this kind of information may depend on the encoding for the impairment. But you know, the encoding for the impairment actually it is individual draft. It may take some time, you know, to move forward the encoding draft. So if you are going to add this kind of impairment information to the double-sound topology, maybe also it needs to take much longer time.
yeah, so we can either move without this, and then later we think about augment.
Right.
That
yeah.
may be better, consistent with GMPLS approach.
Like we did with the
Yeah.
encoding.
Okay. No problem. That's even better.
Maybe you can call it like impairment free and impairment aware, like we did with.
Yeah. Okay. Sounds good. Yeah, this is T WSN tunnel model. Could you next, please? Yeah, so we did clean up quite a bit. Basically, we augment 4 things. We augment T tunnel model for basic configuration and global path constraints for WSN wavelength assignment policy. And we also augmented IETF OTN types, because OTN types now defines client signal for source and destination. So we think that that's a good idea to augment OTN type. And another one is IETF WSN type for wavelength assignment policy for configuration. And we augment IETF path computation RPC mode for stateless from Italo and Sergio's documents. So it compiles it magically. So I'm so happy with that. And then this is NMDA compliant model. Next, please. Yeah. So this is basically IETF WSN tree look like. As you see, for augmentation, we only specify what is specific to WSN TE. Next, please. So we believe that this is a good base for working group adoption along with the WSN topology model. Okay.
Any questions? Everyone wants to go to the social.
Okay. Okay. Thanks. So you will go to the list.
Yes.
Okay.
Now, actually, yes, few words about that. We want now to speed things up on Yang models.
Okay.
This means WSON, FlexiGrid, OTN, microwave. This is the highest priority because the market window is open now, and we need to hurry up. Italo is going to save us 10 minutes with this speed.
Okay. Hi, everybody. I'm Italo Busi from Huawei. I'm providing some status update of the Transport MBI design team. Next, please. Okay. So these slides summarize the goal and deliverables expected from the design team and our working methods. I think we can skip it. Next one. So we have done some work on the use cases that we are analyzing, and we have 3 basically drafts. One draft that describe what are the deployment scenarios that we want for which we want to see how the existing Yang model can be used, and we have 2 drafts which are describing in details how these models can be used to address specific deployments, in particular single layer, single domain deployments, and single layer multi-domain deployments. The first draft is about the generic applicability statement use cases, which has been recently adopted as a working group document, and we have made a few minor changes to clarify the intention of this draft. We don't see major open issues at this moment in time on this document, and we have some, as a next step, what we are looking for is to do some cleanup of the text to avoid any misunderstanding of what we are talking about, and we are looking for further feedbacks from the working group. Next. And for the use case number 1, so the analysis of single domain and single layer, we have published the revision from the last IETF meeting, where we have started to analyze how the model can be used to support Ethernet services, Ethernet point-to-point services like EPL and VPL, and OTN client like STMN, Fiber Channel over OTN. We found some open issues on how to use this model, and we have some questions about how the T topology mode attributes and the I2RS topology attributes fit together. We are going to analyze. We have a minor issue about how to integrate the JSON code that we are developing into the draft. It's going to be fixed in a few days. So the next steps is to resolve this issue and to complete the document. And for the first issue, I have a dedicated slide. Next one. For the use case 3, which is a multi-domain single layer, we have a new draft submitted in this meeting. We have started to analyze one of the major problems with multi-domain is how you stitch together the interdomain link. So the interdomain link is reported as external domain links by 2 PNCs, and the MDSC has to be able to understand how they are glued together. We have started to good discussion, but we have not finished. So we have to finish it, and we have to complete the rest of the document. Next. So we have sometimes on the open issue. So the big one has been on the multi-domain is the interdomain stitching. We have been able, thanks to the help of Igor as well, and the T topology social thank, analyze the plug ID. So the plug ID has been analyzed in 2 particular, and we see that it supports 2 cases. One case where this number is assigned by a central authority and configured on both PNC domains and reported via MPI to the MDSC. The second use case is when the 2 edge devices auto-discover the link via LMP, and the information that is auto-discovered is reported to the MDSC. And by this discussion, we noticed that the plug ID syntax had to be changed, and the T topology has been changed based on our feedback. So we have delivered the feedback to the T topology model. That's was one of our tasks. And based on this feedback, we have the structure allows also the coexistence of different mechanisms. So you can have a central authority on some links, discovering on the other links, there is no conflict, or you can have also different auto-discovery mechanisms running in your network. And it should be, everything should work with plug ID. A second issue, the second option, which we have not finished, we didn't have time to analyze before this meeting, is that we can configure either on the PNC or on the BSC how the T-node ID, LTP ID on one side is matched to the T-node ID, LTP ID on the other side. The configuration on the PNC is already described in the topology ID from TIS, and there are some issues described there. The other case is not described because it's more an MDSC internal configuration. What we are asking now, we are to analyze this one, and we have to understand whether there are some issues with the option of plug ID that is analyzed that requires to look for other mechanisms. And we need to understand what are the pros and cons of this alternative solution. And in case we have more options, what happens in case for interoperability? If different PNC and MDSC make different implementation strategies, what is going to happen? So these are the major issue.
I have one question
Yes,
on the plug ID. Does it allow to understand whether the relationship between the 2 topologies is peering or client server? And
well, I think the link is to be peer by definition. The interdomain link is at the same layer.
You're right.
No. Okay, so any input, any comment on this open issue from the working group? Okay. We can. Next one is about the client services. Okay, we have looked at the scenario, and we have found that with the these work documents, we have some questions that It's not easy to solve with implementing only T-tunnel and T-topology. The first question is on which topology the Ethernet or other OTN clients like STMN, Fiber Channel, access link should be reported in the OTN topology, or should we have other topologies? And if they have these access links and we have the OTU tunnel, we need to configure the relationship, because the T-tunnel is between P's, and then we need to know which access link goes into. Once you set up the T-tunnel, you have to say on this service is an association between the access link and the T-tunnel. And also in case of EVPL, you have VLAN ID classification criteria that has to be configured. VLAN number 1 goes over tunnel number 1, VLAN number 10 goes over tunnel number 10. This information is not in the current models. And we have started to analyze two options. One option is a set of drafts that will be submitted to this working group, which are on the agenda. And basically those drafts have been triggered by the discussion. And another option we can analyze is what OpenConfig is doing. That was raised a comment. Let's look at that. And we have not yet started the complete analysis, so we have not taken any decision as a design team. We are open to suggestions or comments from the floor.
Any comments? So I have one comment actually. I think actually I would like to suggest the authors or design team to take Eagle's draft as input, because that draft also talks about use cases and describe how to use the young models for the transport network. So that's a good foundation for the design team to take as input.
Yes. We are taking it, but we will take it. We will add it to the references. We will see whether it's missing there or whether. Absolutely. Yeah.
Okay. Thank you.
Okay. Thank you.
Okay, hello. My name is Hao Mian, and I'm going to present the 3 works about the young models for OTN client signals. They are respectively the service model for OTN client, topology model, and the tunnel models. Next. So firstly, we are going to introduce about the client service model, which is different from the previously defined topology model and the tunnel model. So the most important issue for here is we need to understand where do the different models sit. So considering a multi-layer network scenario, there is usually a higher layer as a client and the bottom layer as a server. So usually we have defined separately for each layer where is the topology and the corresponding tunnel by doing the tunnel is usually configured between the boundary of the nodes calling the TTP, and this is used to configure the network. Consider the client service, it is usually defined in between the UNI reference point in the network, which can be the kind of reference point between the client node and the server node for the interlayer link. So this means that the server tunnel is usually used to carry the client service. As the tunnel has this kind of relationship, so the tunnel is different from the client service, and they should be described in separate models. The next, please. So here we are using an example to describe how it is applied between the different controllers, and we use the Ethernet over OTN as an example. So considering the MDSC and the PNC interaction, the first step would kick off the request of Ethernet service. So that is the client layer stuff. And correspondingly, given this kind of request, the PNC would respond a message to set up the OTN tunnel. This is how the server layer would respond to the stuff. And given this tunnel setup, so there would be a kind of virtual link, which is the dashed line between the Ethernet service that is a part of the client layer and appears dependent on the OTN tunnel, and there would be corresponding topology change, which means that the controllers also need to update the Ethernet topology. And if we only focus on the Ethernet perspective, we can see that given this kind of appearance of Ethernet link, we need together to update both Ethernet topology, and then we can trigger the tunnel establishment based on the Ethernet link. And this kind of tunnel can be used to carry the service from the upper layer of the Ethernet. Next, please. So currently, we use this table to summarize how many potential service types can be in the client service. This comes from the RFC 7139 about the OTNGP. And currently, the draft only contains the Ethernet details, and we are going to develop other kind of service types in the future version. Next. So then we would like to have a very quick view of the client service model and our young tree. So the first one is the client service model. So it is mainly used to requesting the client service by specifying different service attributes, like very global, high-level descriptions and the service type. Next. And then this young tree shows the parameters contained in the Ethernet topology model. So this can be used as when we need to update the client layer topology, and this is an augmentation to the TE topology model. So this work, in this current version of the draft, we use Ethernet as an example again. So finally, the model is about the Ethernet tunnel, and this model would be needed once there is a tunnel in the client layer. So again, Ethernet in this draft. So there are also a few open issues in the current draft. The first problem is currently only the Ethernet service is included, and we need to add others. And also for the Ethernet, so we also need to align with some other young models in the I2RS mode and NAND mode work, because they also have some kind of layer 2 stuff, and together with IEEE 802.1. Then we are not sure if there are different client models like SDH, Ethernet, and kind of fiber class, whether they have a common part to be generic, or there can be separate models. We will firstly define those different kind of models and find whether it is. And currently, the model is still not NMDA compliance, but we first want to clarify the technical stuff and then make it an NMDA. So here we would like to confirm with the working group that the work is useful, and this is actually, as Italo presented, this is triggered by the discussion of the design team, and we would like to work together and fit into the use case in the scenarios. That's the presentation. Thank you.
Can I have a comment? So definitely, I think this is Amy from Huawei. Sorry. So definitely, I think this is a very useful work, especially on the Ethernet, because also Ethernet is a very one of the popular client servers, even on microwave link. So we would like to see such work. And I also have another comment. If one of the common use case in our case is that we will deploy Q-in-Q Ethernet model, Ethernet service. So I'm not sure if the current model have addressed that, or it should be addressed in future.
Currently, there is no Q-in-Q stuff, but we can integrate in the future. I agree with you that the microwave is a potential server to the Ethernet service, right?
Yes, and not only microwave. I mean, I see this. I probably already did this comment on the mailing list. Probably generalizing this work is something that is really useful. As usual, my suggestion is to try to see what is the generalized part of it, bring it to this, and then do all the technology-specific extensions in CCAMP.
Yeah, I agree with this approach, but I would like to emphasize that this work are basically augmenting the TE generic models. So it's the scope would be still for TE.
Yeah, I think this is a good start. But in regards to layer one, actually we have a layer one connectivity service model. So
you anticipated my second question.
Right. So I think you don't have to do everything here, but focus on Ethernet and layer zero service. If it comes along, I think that should be separate service model. So I think if you focus on Ethernet, that's good base. I think just to move on.
Page 2. Yeah, I agree. Actually, in the slides, this page focuses on the network side, and this is a kind of supporting the interop on the MPI. So I don't think it's a conflict with those kind of LRX service model. But but I would like to. I tend to agree with this because there is a slightly terminology issue because both of them seems to be called as service model, but actually I'm not an expert for terminology, so we would like to hear from the working group whether there is some better name of such kind of work.
Okay.
Yeah, Italo Buzzi from Huawei. 2 comments. I think for Q&Q, if it is a Q&Q point-to-point tunnel, it's the Ethernet tunneling that is supported here. If it is a connectionless Q&Q, then we don't have yet analyzed that option. So it depends on which type of Q&Q implementation you are looking at. And I support, this one is for the MPI, is not for the CMI, while layer 1 CSM is for this. So you need to translate the layer 1 CSM request at the MDSCE into these commands that has to go to the PNC to set up the physical network element. And maybe we need to align something when we go to the generic client to make sure that the same ID is used to some extent. So the same client is called in the same way, otherwise you have too many translations.
2 comments, just ensure. Number 1, IEEE 802.1 is working on Ethernet and Q&Q and anything relevant to the work, so it should probably be aligned. I'm not sure whether they are on the work. Probably you should use the Young catalog to check, but it should be aligned. Number 2, I2RS, as we know, is going south. So you had a point of aligning with I2RS. If I2RS is not there and drafts are in limbo, maybe we shouldn't. Or we need to figure a way so it's not a liability for us.
Okay.
Good morning, good afternoon. This is the presentation about the Young data model for layer 1 CSM, so layer 1 VPN. The starting point for this work was the RFC 4847 that provide a framework and a service level requirement, and in general describe all the deployment scenario for layer 1 VPN as a service. So, and this draft want to make a Young data model for a layer 1 VPN. We prefer to call connectivity service model because we cannot talk about a layer 1 VPN as a service. So in order also to make the difference between layer 1 CSM with the layer 1 2SM and the layer 3 SM. So next. This is the first deployment scenario that is simple. This is very simple because we are talking about a customer that want layer 1 VPN services to a provider. So the layer 1 CSM in this case is the modeling of the interface between the customer service orchestrator and the network controller. So this use case could be not so common, but is useful to explain also the second scenario. If you can go to the next slide, where we have a very common use case, in particular in the same organization. We have the service SDN orchestrator, service SDN controller for layer 2 or layer 3 services. And we have the network SDN controller for layer 1 VPN. So in general, this is the use case where we have a layer 1 VPN, so a common backbone, a common transport network layer that is shared by different services. And in particular, different services can be different service departments, for example, of the same organization or the same service provider, and so on. So this is interface makes sense in this case, and make also the difference with the layer 2 SM and layer 3 SM. So if we go to the next slide, we can see this difference. Okay, the architecture is the monolithic architecture, so it's very simple. For now, is auto scope the multi-domain and multi-service provider use case. But just to make you to understand that we have the layer 2 SM and the layer 3 SM, that is the interface between customer and the service SDN orchestrator, while layer 1 CSM is the southbound interface between the SDN controller and the network controller. For the layer 1 VPN for external customer, okay, is less common for now, but we have to consider it. Next. Okay, this is the first proposal for the service model. The structure is very simple and follow the one that we use for layer 2 SM and the layer 3 SM. So there is basically classification between split between access and access parameters and service parameters. And please check, and if you have comment, we can change and we can discuss. So finally, we have the summary. So some operators are involved in the draft. Telecom Italia, Korea Telecom, Telefonica, and in particular, as I mentioned before, in the context of a service provider network could be useful, in particular between several departments, the one that are more service oriented and the department that are involved in the transport layer. And this can be considered in the scope of the CCAMP working group because it's about layer 0, layer 1 technology. And another question is maybe we need a liaison to MIF for this work. And the authors hope you can consider this work as a basis for layer 1 VPN service mode. Question?
Hey, Dave Senecrow, Erickson. Actually, you took my question and you addressed it there with the MEF. Should we send a liaison to MEF? I would say absolutely.
Okay.
Do you have any authors, co-authors from Nokia on your document?
That are involved also in MEF?
The gentleman driving the work in MEF is from Nokia.
Yeah,
His name is Dave Martin.
Yeah.
So you may, if you do have co-authors from Nokia, you may want to get them to reach out to Dave.
Okay.
The liaison to EMEA. Liaison to EMEF has been brought a few times this week, not only on layer 1 VPNs, but also on lifecycle management, some other work they're doing. So from AB perspective, we are looking into it and it's going to happen.
Sergio Berotti from Nokia. Yes, I'm contribute to these drafts, but Dave is aware of that. Okay, he's not happy with that because there is not official documentation from MEF. So I think that the liaison is absolutely needed make aware both of the standard body of the activity. This absolutely.
Yes, I agree. This is Young, and also in order to have a liaison, though, this has to be a working group document. Otherwise, there's no point. So
this is the first point. You're right. And
right.
the second thing is that the IETF should be aware of this work going on in MEF. But only some companies have access to this document. So this is another
Mr.
issue.
Chairman, let me ask a question. Does it require a working group draft to have the two CCAMP chairs send a liaison to MEF asking for their work on layer 1? MEF should send it here, but given that MEF just had a meeting last week, and I mean, okay, so we can use the informal channels, I'm sure, but I don't think it would take a working
Yeah,
group
but
draft.
you know what's the problem of the MEF? This document is not available to everyone. This document is not available to everyone.
But my point is this: we can either use the informal channels to go back and ask MEF to send a liaison to CCAMP, since MEF had no idea CCAMP was working on this until, well, they couldn't have because it happened after their meeting, right? Or I don't think it takes a working group draft document for the two chairs to solicit work from the MEF.
This will be great. We rely on your PR skills.
Comment with a hat on, formal liaisons. Hey, IETF's work is open. It's all open, right? And so I would say if MEF participants, are aware of this work here and they think it's interesting to MEF folk, they can just send an email on their list and inform them, or they can access this document. But it's not for us to hear the gossip that MEF is working on something and then we send them a liaison to ask for that information. You can let MEF people know that it's public, right? Give them the link, say if they're interested. So but that's MEF's, yeah.
Exactly.
Okay, I have one interesting comment for clarification. So what do you mean layer 1 here? Do you mean that layer 1 is, audio pipe, or it also includes, for example, WSOund?
No, it's just connectivity.
Just the connectivity, audio connectivity, or?
No.
Because I think people should have the same terminology in mind.
It's not technology. Yeah.
Yeah, because for the young tree, you define the optical interface. What is the optical interface? Actually.
Yeah, but there is also protocol code. It depends. Or we should make some use cases about that. This is some example. Yeah, this is right. But yeah, maybe in the next version we can add an example section where you can make how to use these parameters.
Yeah, right. That will be great. Yeah.
Okay.
Thank you. Flexi.
So next two presentation is flex grid optical networks. First, topology model. Next. Yeah, this is basically based on RFC 7698, and we extended from generic T topology model. Next. Yeah, I think this was the previous one, so we can move on to the tree. Yeah, and it is an NMDA compliant. Yeah, so this is basically current flex grid topology model. Similar to WSOund model, we cleaned up most of overlapping parts, except flex grid specific. The things are listed in this model. Next. And this is a tunnel model. analogous to WSAN T tunnel model, we also augmented from T tunnel model and specify only flex grid specific terminologies and the parameters here. I think it has been a while that this draft has been presented in a CCAM working group, and I think the only issue on the flex grid YANG, I think we study if port should be LTP to be more consistent with the T tunnel model, and the tunnel model. I think the media channel may not be the best terminology, but the original author wants to use that terminology, so that's one pending issue, but it's not a big issue. And another issue is same LTP port model. Doesn't need to use a transponder characteristic, so we're going to look it into to be more consistent with generic model. But other than that, go next. Yeah, so we think that this is good base to be adopted as a working group. And any comments?
So, what are the issues with the terminology? Because this is the terminology of the framework.
Media channel.
Yes, media
okay,
channel,
then,
network media channel, and tunnel.
Okay, you don't want to call T tunnel? Flex grid T tunnel?
Good point. We have misalignment between the framework and the other young models. Please, Dieter.
Dieter Bella, Nokia. First of all, I would like to thank you for incorporating our comments that we provided at the last meeting. I think this is actually good. I have just one comment regarding the available operational mode attribute. This is currently a read-write. I believe this should be a read-only.
Oh, read-only. You're right. Yeah, you're right. This is read-only. Okay, thanks.
Regarding moving forward, as I said before, our priority now is to progress the work on young models for WSON, FlexiGrid, OTN, microwave. So,
okay,
it's in the pipe.
All right, thanks.
Going. Laura, it's you. Which one? Yes. You want to drive with I can. Where the ticket? There are animations. There are animations. That's one.
So I think that this is the third presentation on Flexi framework for GMPLS control plane. This is the fourth version posted, and we've done a lot to the document, and it is basically two things we have been doing. We try to align it with the work going on in ITUT, and as that work is also aligned with the OIF work, we should also be aligned to the OIF work, or the other way around. I don't know. They are basically doing the same thing. Then we took away part of the document, especially we took away use cases. We took away use cases not because we didn't like them, but because they weren't actually focused on the control plane. They were focused on a more generic flexi behavior. And then we have converged on terminology. I think we are pretty well done there. We have done a lot of smaller editorial changes, but you still have a lot of we have some document cleanup to be done. The information we added is mostly responding to two comments we had last time. This is, and the comments were, this is unclear, and this doesn't really capture what you want to do. And I think that's now is well inside the draft. Next time. I did show this last time. I thought we needed a reference model to actually be able to discuss things. And I have asked help from a couple of people who were involved in creating a reference model for PWE3 and MPLS-TP to actually get all the small nits and bits in place. I don't have much to say about this. Next slide, please. Okay, so GMPLS might be used to set up a number of things in a Flexi context. First of all, we could set up a Flexi group. We have one problem where we haven't really converged, and that's on the signaling channel. My understanding, and I think Chile's understanding and RADA's understanding are not exactly the same. But I think we are slowly converging, and we've actually sorted out. I don't see any real problem. It's just actually describe about how it is. So we can do things through an out-of-band signaling channel if we want. We can always do that for everything. When setting up a Flexi client, we actually have a signaling channel available on the PHY, one type of channel, or one channel available. And we also have a signaling channel available on the Flexi group. We could use either. We need to decide how we actually want, how and in what situation we want to use those channels. And then we can use Flexi to actually announce the TE parameters. We can use the GMPLS control plane to announce Flexi TE parameters into the routing system. Next. And then we can actually also use it to set up an vanilla MPLS LSP, and that's actually the example we have in these slides. Okay, so Flexi configuration. An operator could take a number of different approaches. He could either configure the entire infrastructure and leave the Flexi MPLS LSP over Flexi to the control plane only. Or you can set up the Flexi client with the GMPLS control plane and only configure the Flexi group. Or you can actually do everything on the control plane. The discussion there is how do we do with the signaling channel, but I think we have it captured now, so it should work. Yeah, I think that's it. Next. So this is, if we want to establish a Flexi group, we have two boxes, the dotted lines. We have a data plane or Flexi data plane and a shim on each side. And then we have, click once, we have an NMS that are doing the configuration. Click one more. You have the routing system that actually is the ultimate recipient of the information. And then an NMS, yeah, so the NMS tell the two boxes to establish the Flexi group. And then the node inside send the information to the control plane that actually announces it into the routing system. I think it's one more, yeah. So we could also establish the Flexi group from the control plane. And then the trick here is that I thought, and that's when I did the slides, that I actually need the out-of-band channel. Chile and RADA has actually taught me that, no, I don't really need that. I can use the signaling channel on the PHY So as soon as the PHY is connected, there is a signaling channel that I can use. So yeah, click one more. To the routing system. Is that right? Yeah. Okay, go on. So the centralized controller, for example, PC box, whatever, tells the control plane that you want a. You jump too far. Bring it back one. You want to do this. Back. One more back. Yeah. So when the Flexi group is there, the next step is to set up a Flexi client, and now I can go ahead. And then you have a centralized controller, for example, PCE, but it could be anything, and the PC it tells the control plane that you want the Flexi client sent up. The control plane in the two nodes communicate with each other, and actually are ordering the Flexi client to be set up over the Flexi group. So the purple line inside the yellow is the Flexi client. Okay, go ahead. So this is what could be the result. So Flexi capable nodes, blue squares. You have links between those nodes, blue links and yellow links. The blue links are Flexi capable, and you have all the TE parameters. And it's possible to find a way for setting up a MPLS LSP that really requires to be run over Flexi links. So I think you can click one. So you can find a way through, and you can actually do the signaling between the nodes based on, for example, an explicit based on an ERO. Next step. So here I again talking about the approaches that could be taken by an operator. And it depends who you are in the operator chain. So if you own the entire infrastructure and own it all the way up to the LSPs, then yeah, then you might need the control plane only to be able to set up quick restoration. Otherwise, you don't really need it. If you are selling Flexi groups, selling Flexi clients, then you are in a different situation. And you really want to be able to sell Flexi clients in a manner where you can actually guarantee that the Flexi client you are selling to someone is actually reserved exclusively for that customer. Customer might set up more than one LSP over that Flexi client, but no one else can set it up. So that gives you an uninfringible bandwidth. Next slide, please. Okay, so that's where we are at the moment. I would like to stress that I think we are aligned with other people working on Flexi. The draft should be pretty clear at the moment, and I think what we would like to do is now have a good review. I asked a couple of people that I know do good reviews to look at the document. Please, as a working group, do it also. We need that. But I don't think we have any showstopper now to go ahead and accept it as a working group document.
Dave Senecro Bergson. So there was a liaison to CCAMP, I believe it was months ago, from the broadband.
Prior to the previous meeting.
Yeah, from the Broadband Forum, letting CCAMP know that Broadband Forum is doing similar work on a reference architecture and nodal requirements. So it would be good for them. There's been a lot of discussion in those groups on what is the applicability of GMPLS to Flexi, and there's been a lot of confusion, to be honest.
So I would
it would
say
be
that
good to liaise this document. I mean, obviously, it's public, but it would be good to send a response liaison back to BBF and say, look, we think if this gets adopted, look, we think this is stable. Here's what we think the applicability of GMPLS is.
If we're going to answer the question on what the applicability is, actually, false protection is one thing, and the other one is actually if you require to run over.
But so your diagram where you're showing the selection at the client layer of Flexi capable links is the first time I've seen that type of architecture. What I've seen in other sessions has been the signaling of Flexi, some mysterious Flexi information that allows a Flexi path to be created through the network at the Flexi layer. And their question comes, right, yes, exactly. The question comes in, what is the label in that case? And is there something called Flexi switching? And categorically, people deny that there's no Flexi switching. And yet, how does one create a Flexi path without Flexi switching? This is the first time I've seen something that even resembles a path through the network, but it's a chain of Flexi links.
What we are actually communicating is link capabilities that the path require, and that's why we need the routing system.
Just one question for clarification. Could you scroll up? I think here you mentioned the MP, RSFP. Do you just use this as an example? It could be maybe other RSP, just a client layer RSP, that's fine.
I couldn't really hear you. Can you speak to the mic?
Okay, sorry. So I just want to ask the Flexi client setup triggered by request for MPS RSP setup. And here you use the MPSP. As you know, that maybe we can use Ethernet to carry other traffic, and maybe some
I can try to answer, and if I see if I understood the question. So if you have the Flexi groups established, and you want to set up an MPLS LSP over those nodes, you need to also establish the in-between node link on the Flexi client level before you can set up the MPLS LSP. Am I clear?
Let me ask a question in another way. So, does the MPLS LSP here has a strong relationship with Flexi? So,
that's the. I don't can.
Should I take a stab at this? So I guess the question is, what is the relationship between the LSP that you're talking about setting up here with GMPLS and the Flexi that's set up underneath, and how do they relate to one another? Because let me say a common misconception is that you're using Flexi, you're using GMPLS to set up the Flexi groups, but that's not what you're doing.
So actually, anything that is established in the Flexi layer, group or client, that is actually announced to the into the routing system. The routing system knows what the quality of or the capability of the links in the network are. And here we actually say that we need T parameters to actually describe the T links. So when setting up an LSP, you can pick the right type of link.
Okay, I think
was that an answer to your question?
Yes.
So, David, I think you are required to speak to the mic.
Yeah, exactly. So instead of Flexi between the two nodes, they're using lag, right? And so at some point, the lag bundles 3 links together and then announces to the routing system that this is one aggregated link of so much bandwidth. It's really no different than what's happening here. The Flexi bundles are being connected together and then being announced to the routing system as a constraint.
Okay, Gabriele, Dieter, and then we have to cut the line.
Okay, Gabriele Galimberti, Francisco. Do you think to extend also the LSP to the case where actually the LSP is carried over a DWDM network, so that your LSP capable interface is connected to an LSP capable transponder, and then you have a uni interface in between? This is the question.
So again, I'm not exactly certain what you're asking. You're just saying.
In other words, the shim connecting the two LSP capable nodes may be a DWDM network. At this point, you need to interface your interface, the FlexC capable node interface to a LSP capable transponders, and then you have a uni signaling over there to negotiate the bandwidth.
I think the answer is yes, but I'm not exactly sure. The nodes we've been looking at can take in, well, an LSP on one side and actually map it down to the FlexC client. That's, I don't see a problem.
Okay, thanks.
Dieter, Nokia. I would like to echo what Dave just said. I also get comments from experts, from my colleagues, who are saying that this draft assumes that there is FlexE switching capabilities in the
It does not assume that it's FlexE capable for switching.
And secondly, I think there is also a locking mechanism defined, which would allow to change the bandwidth of the FlexE group, which is also something that's probably not aligned with the FlexE implementation agreement.
I don't get that really. Can I see it?
Can you repeat, please?
Yeah, there is an administrative locking function defined, and you can actually then add or remove files from that group. And I think that's not aligned with the implementation agreement of FlexE.
Okay.
We can take that offline.
Yeah, I can take it offline. I'd be interested because but I thought you also said that they assumed that we do FlexE switching. We're not. Definitely not. And it actually were a hint that we could do it in the version 2 of the draft, but it's been out since then, and that's 4.5 years. Okay.
So, okay, I think more questions can go to the list. Okay.
Thanks a lot.
Okay.
Hello everyone. This is Chile, the president, and this is presentation includes two drafts. One is the beyond the 100 gig framework control plan technology, and the other one is the signal extension. So, okay, thanks. During the program meeting, the first version of the model draft, the framework draft was discussed, and we also have some questions, some topic to discuss, which what is OTOCN or OTOCN DSM or OTOCN ISP discussed, but we have not included this in the framework document. So just some changes were made in the draft at a new section to describe what is this ISP. So actually, the ISP is a number of end-to-end instances bound together as a group. So that is the definition. So, and what the control plan need to do, the control plan it just need to finish the setup, finish the bounding of this instance, as well as indicate some slots that may be available. This is the first change, and second one is the second one is setup of audio K over audio CN, and after that discussing, we think this can be solved by reuse the mechanism defined in IFC 7139. It's because as one configured audio CN link has almost the same feature as audio K, so the beyond 100 gig control plane technology mainly in this draft should focus on setup and focus on the bonding of this instance. Also, some use case sections I combined into one category as they all represent the transportation of non-OTN client signal over OT flex and then over OTN connection. That's some restructured job. Okay, next. Okay. And the following is the signaling draft. Just before this IETF meeting, their version of the signaling architecture was uploaded. So next please. First, let's take a look the extension included in this draft. That's our overview. A new encoding type, Z.709 audio CN defined because in the latest version of Z.709, the audio CN actually plays a digital section layer rules instead of a digital path layer, which is the rule that audio K played. Also, for new payload idea introduced, they don't exist in the 2012 version of Z.709, and they are listed here. So next. The traffic parameter for audio CN is also comparing to the IFC 7139. There are also some changes to this object, the traffic parameter. Currently, we this object only includes the signal type, which can be these 3 different signal type, and the number of instances requested, and the bit rate and MT. We just try to reuse these 2 fields, which is also described in the IFC 7139. Okay, next. Okay. Next one, we define the label. We use the label to indicate the instance bound in this audio CN or in this audio CN. And the label actually include n blocks, with each blocks include the instance ID, the bitmap length, and the slot bitmap, and the number of available slots. And the bitmap length and the slot bitmap here is actually used to indicate the presence of available slots when signaling is used to set up the audio CN path or audio CN DSM path. Okay, next. Oh, sorry. Also, some other TLVs are defined. We define a new TLV, available slots collection TLV, which is a new kind of ISP attribute TLV. It's this TLV is extended to collect the available slot information for end-to-end audio CN ISP. It's because one audio CN ISP may span multiple audio CN or audio CN DSM link. Also, the interface RD, the SVP hub object must be used in reservation methods, and it contains several TLVs to indicate which component interface is used to carry a specific audio CN or audio CN instance. So, okay, thanks. This slide just gives some description of how to use object or TLV defined in the signaling draft. For actually, in the current version of the signaling draft, we think this is still a multi-layer scenario, or we consider that it's a case of a setup of a hierarchical ISP. It's because just like example, one end-to-end ODOC3 ISP can be carried over 3 different ODOC or ODOC and DSM ISP which are connected together. So this here just give some description of how to use the traffic parameters for requesting the ISP, which cover the case of say N, say DSM with available slot.
Yes. You have 1 minute.
1 minute. Okay. Thank you. Okay. Also here we just give some description of the label. That's how to set a label, how to set a bitmap, slot bitmap. Okay. Next. During a discussion, we also have some open issue. I think we need to discuss this week. First one is OTOCN, and OTOCN cannot be switchable. So why is the so-called end-to-end ISP? Because there is no label to be switched. So I think we need to discuss this. Also, another issue is how can we define the bounding action? Can we call this the setup of ISP? It's currently no answer. We need to discuss about this. And the third one, so is there a bounding of OTOC instance in one OTOC? Because some authors think that the OTOC ISP may not need to be explicitly specified. So we need to solve this problem, I think. Okay, next. Next step, I think we need to keep discussing the framework and the solution, and some alignment work need to be done between the framework, signaling, and the routing drafts. Also, we need to discuss whether the use case document in the framework draft still need to be kept, because there are so many use cases. If not, we need to remove them. Okay. That's all. Also, tomorrow morning we also will meet at the registration desk at 9:30 a.m. to discuss about this. If you are interested, you can.
Okay,
join.
Thank you. Next, please.
Hello, my name is Zhe Yufan from Huawei. So as a routing extension is closely related with signaling and the framework draft, so we just upload this routing extension merge draft to just before this IETF, and this draft is still in progress, and the detailed technical points are still under discussion. So I will. This draft actually merges 2 drafts about the routing extensions for beyond 100 giga OTN, and all the extensions actually mainly focus on the SCD part. And next. So for the first draft, and this draft has been presented in previous IETF meeting. So in this draft, type 3 bandwidth of TLV is defined for the ODOCN container, and the TSG is extended for 5G granularity. The unreserved bandwidth is not included, as ODOCN is not switchable. Next. And this is the detail of the label introduced in the first draft, and it is also presented has been presented in previous IETF. So next. And for the second draft, extends the type 1 bandwidth of TLV for ODOCN container, and as ODOCN signal type is only has one granularity, which is 5G. So the TSG is not extended, and the number of TS is used to indicate the number of available tributary slots, which means the tributary slots can be occupied. It's different from the can be allocated. How to say? There are 2 Okay, this is ambiguous actually. This termination. There are 2 bits in the for each audio CN time slot. It can be occupied or it can be marked as unavailable. So this is used for the availability. And so in the merge draft, actually the merge draft merged the two drafts, and so the technical point for the ISCD part is actually combine the two drafts and defines a type 3 bandwidth sub TRV and extend the 5G granularity, as there may be more granularities for the audio scene. So, and a bitmap is used to indicate the exact locations of the unavailable tributary slot information. Although it's as Chile has introduced in the signaling drafts, although it's unavailable TS information is described in the signaling part, but actually I think this information is actually about the node capability, so which should be carried in the routing advertisement. So it's added in the merge drafts, and so here is the difference comparison of the difference of 3 drafts. We can see that the merge draft can combine the two drafts. First the RSP encoding type for the audio CN and bandwidth sub TRV type, and extended tributary slot granularity, and define a unreserved bandwidth for the audio CN connection setup, and the information about the available tributary slots. And so next step we are open to discuss and revise the technical detail for the merged routing drafts, and any comments are welcome. Thank you.
Comments, questions? I have a quick one, which is since you are defining a new switching capability, please consider using the generalized SCSI.
Generalized SCSI. Okay. We will try to consider this.
Okay. Thank you. Next.
Hello, it's Haomian from Huawei again. I'm going to present this work talking about the interworking of the GMPRS control and the centralized controller system. So we are going back to GMPRS again. And firstly, I would like to introduce the motivation of this work because we have been working on the GMPRS as a control plane technique for a couple of years, and before the controller emerged, the data plane is consistent, is working consistently with the control plane. But nowadays, with the evolvement of the controller system, we have also developed a kind of a branch of solutions that how the controller system interact with the corresponding device. So it would be interesting if we can further understand, okay, how the kind of distributed flavor of solutions like GMPRS and the centralized flavor of system like controller system, they can coexist and work together. So example protocols in the GMPRS control plane may include the RSVPT protocol for signal and the OSPFT protocol for routing. And correspondingly, there has been a few newly emerged technique like RESTConf protocol and Young model defined for a kind of centralized device configuration. And we also have a kind of PCE protocol to use as a kind of centralized routing or path computation. And the objective objectives of this draft can be divided into 3 different issues. Firstly, we would like to check the current architecture from different functionality, that we make sure that the current architecture satisfies all of the requirement. And we would like to understand how the existing solutions can be applicable to this kind of architectures. And during this procedure, we believe that there can be a kind of potential gap analysis. And for example, next page, we show an example in the GMPRS together with the ACTN architecture. And as you can show, as you can see in this figure, this is a kind of multi-vendor, multi-domain stuff, and we have GMPRS as a distributed control plane technique, while we also have the REST compound and the Young model as MPI solution. So there, we need a kind of consistency and neat approach to make these 2 systems interwork together. And in this page, we try to list a few different consideration on how this interwork with each other. For example, on the southbound interface between the PNC and the interface, how the GMPRS can help report the topology. We may have different alternatives like PCERS from the centralized style, or we can have a kind of OSPFTE in the distributed function. And the second issue would be like considering the interdomain link, MDSC need to gather information, but usually it is a kind of stitching from the information reported from PNC, and how the GMPRS can represent this kind of information to PNC would be a key approach to this problem. And correspondingly, the next issue would be interaction request for the RSVP, because usually given a kind of PCE protocol, if we initiate the path establishment from the head-end node, it would run the RSVPTE signaling accordingly. But actually, given the multi-domain case, there would not be an explicit ERO function to describe each node in the other domain. So that would be taken care from the other kind of controllers. And finally, the most advanced issue would be the kind of protection and recovery. This would also request a very accurate interworking mechanism between the device level and the controller level. So some kind of intra-domain protection and recovery is very different from the interdomain operations. So here we are trying to introduce some issue and examples for our interworking consideration. And in the next step, we are going to bring more details and describe some typical interworking scenarios. And during the procedure, if we detect any kind of gap, we would like to continue our working on extending those kind of protocols. But before doing that, we would like to confirm with the working group that we are doing the right job to say that this work is useful. Okay, thank you.
You go first.
Dieter Beller, Nokia.
Louder.
Actually, I think this is a good piece of work, because it shows actually how GMP-less networks could actually interact with the ACTN components. Can you go back to the previous slide? I think I can answer easily question number 1. The PNC, of course, of each domain could actually listen to OSPFTE, and then it gets the topology.
Yeah. I think it is not difficult to have one answer, but it is really hard for different people to have the same understanding on how to solve each of such kind of problem. So it may be clear to give better description on how this work is done.
I agree with Dieter on the usefulness of this work. I'm again wondering what is the relationship with the transport MBI design team. It's probably something that fits in there.
I think it would go a little bit beyond the MBI or the MPI in the ICTF because it is more device level interaction and some device attributes may be taken into account.
Ito speaking, I agree with Damian. I think in the design team, we are looking more about how MDSC and PNC interact with each other. We do not care because we are looking at the MPI and the interoperability space, how the PNC translates the information that the MDSC provides into action in the network. Also because in the network you can have GMPLS or whatever you like. So I think this is second also the point. This is useful because it complements and say, when you get this information and you are running GMPLS, what the PNC can do, that's useful information. Since GMPLS is one of the major SBI protocol, especially defined here. Thank you. Okay.
Youngli Huawei, yeah, I think this is a very useful work. My only question is, are you also scoping PSAP within this picture? When you say GMPLS, do you also include PSAP or not?
Well, currently I categorize the PSAP as a part of centralized path computation mechanism. But GMPRS is a kind of distributed ones. But you are right, they are highly associated with each other on the SBI, right?
Yeah, so my suggestion is maybe working with PC working group together with CCAMP to figure out a little bit bigger scope of alternatives because PSAP, centralized method is now, if I understand, based on offline discussion, it's going to take off. So this is very useful work, but in terms of scoping, right? So if you consider that, that would be.
Yeah, I think that's dependent on the result of the gap analysis.
Right.
We have a comment from Julien. He says, it seems to me that there is much overlap with existing PCE documents, like 4655. Thanks, Yang, I agree with you.
Just a short comment in the sense that I support this work, and it is very interesting because for the first time it's tried to define interworking between GMPLS and SDN control, and also open the door on the need what mentioned by Italo now. Yes, in the transport design team we just analyze basically MPI interface, but this draft make clear that also work on the SBI, I think IETF has to do. It is important to do.
Yeah, Rüdiger Kunze, Deutsche Telekom, same direction as Julian just mentioned. So what kind of problem do we want to solve here with this solution compared to the existing solutions that we have with PCE? So if it's going more to SDN, so then PCE and netconf are almost not the right mechanisms to address this here. So then I2RS maybe is the best, is more or less a way to move forward.
Who said that netconf and PCE are not SDN protocols?
Depends on the definition of SDN. Just to answer your point again, so for me, SDN is programming the forwarding plane of a network, and yeah.
You can do it with netconf and PCE and PSAP.
Okay, this is Gabriele Garimberti from Cisco. And I would like to talk a little bit about the possibility to extend the current signaling on the SSON, also to cover the carrier part and the interface, the client and network interface. Next, please. So even if we have, let's say, pretty excellent 7698, sorry, that is defining the framework for the SSON, and also 6699 and 7792 to define the signaling of a media channel. We don't have actually the possibility, in case we want to, let's say, define and signal what is inside the media channel between the two clients. Next. Again, please. Okay. Here is the picture that describes a little bit the issue. So supposing that we have an edge node that has a multiple DWDM interface or SS1 interface connected to the client, to the core node, and then suppose that the edge node wants to ask for a media channel to connect the tail end node. So basically, okay, GMPLS can calculate the media channel, can define the path, can define the N and M value, but cannot, or if it is able to do, to define the frequency of the different subcarrier, then has to signal to the edge node this frequency. Next. And on the other side, the edge node, how can ask to the core node what kind of circuit it wants. For example, can define number of channels that can be fixed or maximum, and can define the total bandwidth. For example, over than 4 carriers, the edge node can ask for a 400 gig channel, or maybe an 800 gig channels, and then let the GMPLS calculate how to implement that. I mean, for example, 400 can be implemented with 4 channels, 4 carriers, running at 100 gig and a specific modulation format, while can be as well calculated and implemented using just 2 subcarrier running 200 gig and also, again, a different modulation format. Go ahead. On the other side, when the GMPLS calculates everything, has to tell back the edge node about the modulation format, the FEC, the baud rate, and also the position of the subcarrier inside the media channel. So J and K are reported to, next slide, are reported and related to the media channel center frequency and, of course, the media channel width. On top of that, next, please, we have defined also the relationship between the carrier and the port, and also the carrier power. Very quickly, I think we address a real issue here, because we realized right away during the implementation of this SSON that something was missing. And I would say we are available to explain in detail why something is missing and how the real issue is addressed here. So I would really encourage to either meet in person or run on the mailing list any comments, and we'll ask. Thanks a lot.
Dieter Beller, Nokia. I think we don't have to rediscuss again what we have discussed in the past. I do have reservations. I know this is an experimental draft. On the other hand, this is specifying a proprietary solution, so that's just for the records.
Thanks, Dieter. No, really, we again, I encourage you to discuss what are we are addressing here, because even if you don't have yet this kind of problem, you will have soon to solve. Thanks a lot.
Thank you, Gabriele.
So this presentation addresses two drafts. The first one, I just want to explicit mention that Nokia and Dieter is only supporting the first document here. Yeah. Okay, so based on the framework document dealing with the optical interfaces that are not part of the managed domain of the optical network, so managed by a different network management, for example, we are using LMP and the extensions of LMP here in this both documents to exchange the properties of one side the optical line system and on the other side the interface itself. We defined certain or different sub-objects based on RFC 4209 here in these documents. So first of all, to negotiate the capabilities of the line system and of the transponders. So therefore we added the application codes and the application identifiers. We are supporting as well a superset of parameters that are defined in the current specifications of ITU-T. I have to mention the first document that we discussing here for the single channel optical interfaces is on standards track. The second one is an experimental draft. For the second one, we're addressing the multi-carrier optical interfaces for spectrum switched optical networks. So same things, we have to exchange or the parameters here, not for configuration. That's very important, just to figure out which capabilities we have on both sides. Next page. Yeah, I think for the current version, so we updated both documents for this IETF meeting. We did a little bit of bug fixing, not so much things, reshaped the documents a little bit and added some parameters on the draft for the flex grid. Next page. We can jump over this. Yeah. So additionally to the application identifiers or application codes, we added the output power and the current input power for the single channel interface document. So that's one thing we have to mention here. And next page. On the other side, a little bit more parameters are needed to exchange. So all the details are in the draft. You can read it and give feedback to that. Next page. Yeah, and that's the last one. So we want to request feedback from the working group, and we think at least the single channel interface draft is ready for working group adoption. Okay.
Dieter, Nokia. I have a question regarding the new parameters that you introduced, the max pole power difference and the max pole skew difference. I didn't find definitions of those or references to definitions of those parameters.
You will probably see in the next IETF 698.2 that is coming.
Okay, so please add them. Any more questions? Okay. there is another comment from Juliana, but I think it refers to the previous presentation. The comment is experimental, but targeted to CCAMP, not the individual stream. I think it's a counter comment to yours, Julien. Okay, we are ready for the last presentation.
Yes, hello everybody, do you hear me okay?
Yes, perfectly.
Okay, great, thank you. Yeah, so this is a little bit another kind of module. This is a generic alarm module that lets devices present their alarm state. First question, it's hard for me to see which of you will raise your hand, but how many of you have read the module at all? A couple of words?
Some of them. Some of them.
Good. I will keep this fairly high level. So next page, please. Yeah, okay, and the next one. Let's see. We can take the next one.
Yeah, there is a little bit of delay. If you could tell us the title of the slide.
This one is okay. So it's me and Martin Björken that is working on this one. I would like also to thank, there's been relevant input already. I had one this morning from Balázs from Ericsson. I've had good input from Joe and Nick from Adtra, and also Lo Berger from NABAN. So good iterations on the email list already. The main features of the module is a way to represent the alarm list, which means what are the alarms on the system. A couple of things here is that if there is a cleared alarm, meaning from a resource point of view, it's cleared, it still stays an alarm list. There are other definitions of alarm lists out there which behave differently. There is also an Yang feature to support operator actions on alarms, the classical one, like acknowledging. There is what I think a very important thing which is sometimes lacking, which I call the alarm inventory, a way for the system to publish the possible alarms. Today, it might be the case that you get a document from the vendor in the free format and then some kind of protocol, but this module lets you ask the system which device, which kind of alarms will you actually publish. And there is also a way to block and filter alarms. I call it shelving, reusing a term from the process industry, which to some degree is a little bit more mature when it comes to alarms than we are in IP and telco sometimes. And you can also do some administrative actions on alarms, like deleting alarms and purging the history. In some cases, you might have a more telco-oriented management system, and there's also a separate module here which lets you map the alarms into the classical telco standard X733. But note well, this is a separate module. It's not part of the core module at all. Next slide, please. Good. So when we say alarm in this module, we are referring to an alarm as a state on a resource, not a notification. So conceptually, an alarm is an undesirable state in a resource that requires corrective action, meaning this is not for events in general, this is not for logging in general. Every alarm is important and it needs someone to take an action, a human or a software. But the meaning is, don't use this to throw just events into it. It's serious things that someone needs to take action on. If that's not true, it shouldn't go into this alarm module. It should go into logging somewhere. That's the first thing. And the second thing to note is that we take a stateful approach when we talk about alarms. The alarm list is built on...
You have 2 minutes.
Sure. So what's the question? Okay.
Yeah.
So if you look at the list to the left here, when we say alarm here, we mean a resource like a specific interface. Oh, sorry. Go back once more again. Go back to the previous slide. That's perfect. Thank you. What is an alarm? So when we say an alarm, it's a specific resource, could be a specific interface, a specific disk, or a specific detector or something, and then a specific type of alarm. So those two together are the key in the alarm list. It has a severity and a separate clearance flag. So if there are some alarm geeks in the room here, some alarm standards sort of confuse severity levels with clearance. Is the alarm cleared or not? That's one thing. The severity of it is another thing. And so you have a list of the resources, their alarm types, their current severity, and if they're cleared or not. That's the focus of the alarm module. And as a side effect, we will emit netconf notifications, where some modules more stays on the right, focusing on the notifications themselves. We focus on the states themselves. Next slide, please. Good. So here we see the alarm list itself. We will focus on a couple of things. Again, repeating what I just said, you can view the alarm list as a function. So from a specific resource, a specific alarm type, what's the current alarm state? So that's the purpose of the alarm list. It's a function of that kind. It's not a notification log. And again, clearance is separate from severity. So what you see here to the right, you have a read-only alarm list. The keys are resource, the interface, for example, the alarm type, the specific kind of alarm. I will return to that. And those are the keys. That's important. So the time is not the key. The resource and alarm types are the keys. And you can see further down that there is a separate field saying is cleared. Is it cleared or not? Which is separate from the current severity level, which is perceived severity. Then for each alarm, you can have a history of status changes from the underlying resources. So an alarm might go from warning to minor to cleared to major again. So the state.
Sorry,
Sure.
Stefan. So could you move forward quickly?
Yeah, sure. Yeah, I'm coming to the end. This is the important thing. So this will actually be my last slide. The other slides are for reference. So this is the core thing. No, please go up again. Previous slide. It will be my last slide because that's the important thing. No, up again. Stay on the list. So there, yes, stay on this one. This is my last slide. So that's the status changes. You can see the history of what has happened with the alarm from resource point of view. Then, separate to that, further down, there's a list called operator state change, meaning an operator might have acknowledged the alarm, might have considered the alarm as being closed. That's separate list. So there is no thing like an operator clearing alarm. That's two different perspectives. So this is the alarm list, and that's the heart of it. And notifications will be emitted from this one. The other mechanisms you can read in the RFC. You can block and filter alarms. You can query the system. What are the possible alarms that can be emitted? So that's the main thing around this module. So any questions?
Okay, there is no question from the floor, but just a consideration from my side. Well, actually, I'm happy that the draft generated a lot of discussion on the mailing list. This means there is interest. There is also rather support, I would say, since most of the comments were positive. I didn't see any next step in your presentation, but I guess you want the draft to become a working group document sooner or later. Is my assumption correct?
That's correct. And I have good input requirements and comments on the email list which will be worked in an updated version, mainly from the AirTrain guys and from Ericsson. Yeah.
Okay. I think this is it. Thank you very much, Stefan, for the presentation. Thanks everyone for being so fast and helping us closing the meeting almost in time. And see you in London.
Okay. Thank
you.
Bye.